Hello everyone, I'm going to take this opportunity now to start to teach you some of the exceptions to the rule of dominance that were stated by Mendel. Now when I mean an exception to the law of dominance, that means that instead of just seeing really two colors, black or white, we're used to saying that black is dominant to white, and if you're homozygous dominant or heterozygous, you will be black, period. That's not always going to be the case because if you look around the world, see people with different colored hair, eyes, skin color, you name it. There's just not one or two different possibilities. You have many other variations that can be produced, and that's because of just one of these numerous forms of exceptions to the rule of dominance. We're going to start talking about the first one called incomplete dominance. This type of inheritance pattern is expressed when one allele is not fully dominant over another. That means that you're going to have an allele that might be a little bit dominant, but isn't quite powerful enough to completely mask and hide the one that is slightly recessive. So that's what I mean by this statement right here, when one allele is not fully dominant over another. So now as a result, the allele that is slightly more dominant is going to be written as a capital letter like we're used to. So for example, I can write like a capital R for red. Let's say red is incompletely dominant over white. Now, it would make sense for us to use the capital R to indicate red is dominant, but let's read on here. It says that the allele that is less dominant, so what I mean right here, this would be the one that we would consider to be recessive normally. But this allele that's less dominant is actually going to be written also with a capital letter, the same one we gave the dominant one, but we're going to put a little apostrophe or asterisk, you could say, after that, indicating that this is the one right here that is a little bit more recessive than the one that is slightly dominant. Now, how does that come into play? Well, now when you have an individual who is heterozygous, so one big R, and then big R apostrophe for the second slightly recessive allele, this is going to indicate that you're now going to see a blending or mixing between these two colors. And if you look over here at this diagram right here, you can see what I'm talking about. Red is incompletely dominant to white. So the only way now to be red is we're going to use two big R's to indicate that you're red. And the only way to be white is you have to be fully recessive. So you're going to use that new symbolism we just talked about, R apostrophe, R apostrophe. If you are heterozygous, you're going to blend the two traits together. So if you mix red with white, I'm assuming most of you know, you get pink. So all the heterozygous individuals are going to be pink, a blending between the two extremes of that particular trait. Now, the reason why we're using some funky symbolism is a lot of other videos may show you a way to use the recessive allele or lowercase allele also. I don't like to do that because you can get confused quite easily. So, for example, if we were using just regular capital R's and lowercase r's, you'd be fine over here if I said two big R's is red and two lowercase r's is white. But if you're rushing through a problem and you write it like this as heterozygous, you might think it's red while it actually is not with this particular inheritance pattern. So I want you to get in the habit of using a capital R with an apostrophe to indicate the recessive allele. Let's do some examples to kind of show you what I'm talking about. So if I drag this up, and let's look at one example here. It says, I'll pull this over just a little bit more. Red flowers are incompletely dominant over white flowers, just like we mentioned above. Now, I haven't given you any symbolism, so you can choose any letters you want as long as you remember that red is going to be, I'll use the same letter this time, big R. And if that's incompletely dominant over white, white is going to have the same symbolism, but you put that apostrophe after. So in this case, the only way to be red is you have to have two big R's. The only way to be white is you have to be R apostrophe, R apostrophe. The heterozygous condition, big R apostrophe, will give us pink. So let's read the problem here and see what it wants us to do. It says, if a red flower is crossed with a pink flower. So let's write our symbolism for that. As we just said, the only way to be red is two big R's. So I'm going to do big R above a Punnett square. The only way to be pink is if you're heterozygous, so big R apostrophe. Now let's see what the problem actually wants us to answer here. What will be the phenotypic ratio of their offspring if I cross a red and a pink? So let's work this out. Let's do our Punnett square first, the same way we normally do. So big R in this box, big R in this box. Now when we do our cross and we combine the alleles for the two separate parents down below, you want to still put the allele that's more dominant in front. So that's the big R followed by the big R apostrophe. Don't do the big R apostrophe in front because you'll probably end up just confusing yourself. And this one here would also be big R apostrophe. So when I get a red parent being crossed with a pink parent, every time they have offspring, you're going to get literally two possibilities. Two of the four will be heterozygous and they're going to be pink, while two of the four possibilities will be homozygous dominant for red, two big R's. All right, so those are my possibilities. So to answer the question, the phenotypic ratio is going to be, if we write this out, choose some blue here, it's going to be 2 red, 2 pink. And that would coincide with the genotypic ratio we found by looking at the Punnett square here of 2 big R's, 2 individuals who were heterozygous, again using the apostrophe this time to indicate incomplete dominance, and we produce pink. Again, you could reduce that to 1 to 1 if you wish, but that's how we get that answer. Let's do one more example together. All right, so here we go. Drag this over here. For example 2, it says, let's get our highlighter ready to go. In some bunnies, black is incompletely dominant over white fur. So let's do some symbolism. We'll do B. So black is incompletely dominant over white. So what I can do is I can do big B for black. And then for white, I'm going to do the same big B, but put that apostrophe. So over on the right in the picture you see, let me give some genotypes to some of these bunnies here. The white one, which we just said is slightly more recessive, would be big B apostrophe, while black bunnies would then have to be homozygous dominant, 2 big B's. Now going back to the problem now, it tells us that if 2 silver gray bunnies, now where did that come from? Well, silver or gray, if you look over the picture, obviously is in between black and white. If you mix black and white, you get something along the lines of silver or gray. So that tells us that the silver or grayish bunny is going to be heterozygous. So big B apostrophe. So if I cross 2 silver gray bunnies, so let me put 1 silver gray right here and 1 silver gray over here. Let's see what the problem now wants us to answer as we go through the rest of it. Again, what will be the phenotypic ratio of their offspring if we cross them together? So again, we'll fill out our Punnett square, big B, and this box over here, again, I'm going to put the more dominant allele in front, followed by the same capital letter with an apostrophe. Continue through. And now I can do big B apostrophe. So when we look at this Punnett square, we can take note that we have 1 genotype, that's 2 big B's. Then we're going to have 2. There we go, it's finally working. 2 genotypes that are heterozygous, and 1 that is fully homozygous recessive. So we write out this genotypic ratio. I would have 1 individual who is 2 big B's, 2 individuals who are heterozygous, and one individual who is homozygous recessive, again using the apostrophes this time. Now, normally, if this was basic dominance, we would expect to see this individual and these two both having the dominant trait, but that doesn't apply here because we got to take into account incomplete dominance. So our phenotypic ratio now for the correct answer is going to be one individual who is black, the two individuals who will be gray or silver, to one individual, and I'm running out of space already right here, who is going to be white. So I actually have a 1 to 2 to 1 ratio based on what you can see over here, how I highlighted and color-coded the different genotype possibilities. Now, if you want to try to work out some of these problems doing it the old school way, saying black is incompletely dominant to white, and if you can remember that a heterozygous individual is going to be gray, that should not affect then your ability to get this answer right here. However, I've always seen students get confused by doing it the old school way, so I highly encourage you to do it the way that I showed you. Do not do this. Have the recessive allele be capital also with an apostrophe after it. If you have any questions, please get in contact with me as soon as you can. Thank you.